The next challenge that we typically encounter is noise. When I joined for my master's here at IIC, my advisor told me, be thankful for noise. You know why? Noise is the only reason you have jobs. If there was no noise, this circuit technique is from the 80s. Nothing has changed. Essentially, nothing has changed. It is only the presence of these noise and you trying to achieve a higher performance, you have jobs for yourself. So respect the noise, because if you don't have noise, you will go away. So sometimes when there is noise in your system, be thankful that you have something to work on. Okay? And that is also a metric of how much of noise can be removed or can stay back. So if you look at the noise, you have power supply noise. So every power supply will have noise. So every precision system will have an issue. Every non-precision system will have an issue. Linear circuits and non-linear circuits have an issue because everything is applied. So that is one constant problem you need to solve. Second is crosstalk. What is crosstalk? Like I just mentioned in the previous example, some energy from where it has to be the pulse goes into the neighboring pulse. So that is crosstalk. So this crosstalk needs to be reduced. For some places, it is called a near-end crosstalk. For some places, it's called a far-end crosstalk. What do they mean by near-end and far-end? From the transmitter to the input of the channel, and if you return back, you see a very small amount of crosstalk because there is no channel influence. But the moment you have the channel in its influence there, that is the far-end. As the signal goes far back, goes to the input of the receiver, and if you loop it back into the input, you will see it is much more degraded, or there is much more pulse spreading happening. So there is near end and far end crosstalk in all cases. So you will have to work with it. Another thing is high frequency coupling. High frequency coupling, it took me quite some time to understand what it is. But then I went back to the basic physics when we said that any current carrying conductor has a flux around it, right? Magnetic flux. Now every channel, copper line, is still a flux. Though it is on a PCB or on a channel, it is still the current carrying. And inherent essence of it is you will generate a flux. And when you put two lines next to each other, each one will interact with each other and cause noise. Right? Mutual inductance will generate, or a mutual voltage is generated on both sides. It is generally not beneficial. In some cases, it might be beneficial.